Now, real numbers. Now, before going to discuss about real numbers, now what is natural numbers? What is whole numbers? What is integers? What is rational numbers and decimal expressions? And what is irrational numbers? And then rational numbers. And also in this chapter, the important concepts are rational numbers and then decimal expressions, and rational numbers and then decimal expressions, and Euclid's division lemma. Fundamental theorem of arithmetic. Showing given number is irrational. Show that root 2 is an irrational. Root 2 plus root 2 is an irrational. And that numbers. And next one is what is logarithmic forms. But real numbers means in 9th class already is it. What is RF? What are, for example, if any one set is given, then what is the RF of the given set? What is surd? These all are the topics in this chapter. Now first one, what is natural numbers? The numbers which are used for counting purpose are called as natural numbers. The numbers which are used for counting purpose are called as natural numbers. It is denoted by the letter capital N. So capital N is equals to set of 1, 2, 3, 4 and etc. The numbers which are used for counting purpose are called as natural numbers. N is equals to, it is denoted by the letter capital N, and capital N is equals to set of 1, 2, 3, 4 and etc. up to infinity. Now in these numbers, which is the smallest number is nothing but 1 is the smallest number. Now which is the biggest number means in natural numbers they are infinity numbers. So it is impossible to find which is the largest number. So largest number is always be not defined. Smallest number is 1. Then whole numbers. Then what is whole numbers? The set of natural numbers along with 0. The set of natural numbers along with 0 is called as whole numbers. So see, it is denoted by the letter capital W. It is denoted by the letter W is equals to set of natural numbers 1, 2, 3, 4, 1 etc. With set of natural numbers along with 0 is no. So 0, 1, 2, 3, 4, and etc. Here in these numbers, which is the smallest number? 0 is the smallest number. Which is the biggest number means in these numbers also they are infinity numbers. So it is impossible to find which is the biggest number. So what is answer means not defined. Biggest number is not defined, but smallest number is always be 0. And then next one is what is integers? The set of whole numbers along with negative integers. The set of whole numbers along with negative integers are called as integers. It is denoted by the letter capital I or Z. It is denoted by the letter capital I or Z. Now take set of whole numbers means 0, 1, 2, 3 and etc. Set of whole numbers is 0, 1, 2, 3, and etc. Negative integers minus 1, minus 2, minus 3 and etc. Minus 1, minus 2, minus 3 and etc. Now you know already what is number line. On the number line, now right side the 0 are always be positive integers and left side the 0 are always be negative integers. Okay. Now we are in this, what is IRZ is minus 3, minus 2, minus 1, etc. will come. These all are what? Negative integers. These all are whole numbers. These from minus 1 to infinity are negative integers. 0 to infinity are minus infinity this side. 0 to plus infinity are whole numbers. So what is integers? The set of whole numbers along with negative integers are called as integers. It is denoted by the letter capital I or Z. Then next, what is Rational numbers. Rational numbers. Rational numbers are denoted by the letter capital Q. Now, what are rational numbers? What are rational numbers? The numbers which are written in the form of P by Q. The numbers which are written in the form of P by Q. Here, Q is not equals to 0, comma, P comma Q is belongs to Z. The numbers which are written in the form of P by Q. Here, Q is not equals to 0, comma, P comma Q is belongs to Z. Q is not equals to 0, comma, P comma Q is belongs to Z. Z means what? Integers. Z means integers. Here, why Q is not equal to 0? What taking means, for example, P by Q is Z. Now, for example, Q equal to 0, take P by 0 equal to always be not defined. P by 0 is equals to always be not defined or infinity. So, Q is always be is not equals to 0. So, what is rational numbers? The numbers which are written in the form of P by Q. Here, Q is not equals to 0, comma, P comma Q is belongs to Z are called as rational numbers. These numbers are denoted by the letter capital Q. Then, what are the types of rational numbers? There are two types of rational numbers in decimal expressions. There are two types of rational numbers in decimal expressions. First one is terminating decimal numbers. Second one is non-terminating repeating decimal numbers. Terminating decimal numbers and non-terminating repeating decimal numbers. Terminating. First one is terminating decimal. Terminating decimal numbers. Terminating decimal. Now, what is terminating decimal means? In the any decimal number, after decimal point, only defined letters is there. Only defined letters is there. That is called as terminating decimal number. Terminating decimal number. For example, 2.512 take. After decimal point, how many digits is there? Only 3. We know how many is there? 3. Like this are called as terminating decimal numbers. In the given decimal number, after decimal point, only defined number of, only not finite number of digits is there. That is called as terminating decimal number. Only finite means what? Only some. So 2.512 and 1.502, 1.51, 1.2, like this all. Here is after decimal point only one digit. Here is 2 digits. Here 3. Here also 3 digits is there. Like this, in any decimal number, after the decimal point only finite digits is there. It is called as terminating decimal number. Terminating decimal number. And next one is non-terminating and repeating decimal numbers. Examples like this. And also P by Q form is 2 by 5, comma 10 by 2, comma 15 by 4, comma, like this all are terminating decimal numbers. Take division method. 5 by 2 means how much will come? 0.4. 10 by 2 means 5. Like this also, this one also find. All compulsory all are terminating decimal number only will come. Terminating decimal numbers. Now, what is non-terminating decimal numbers? Non-terminating and repeating. Second one is non-terminating. Next, non-terminating and repeating or recurring. Non-terminating and repeating and recurrent decimal numbers. Recurring means what means? That same numbers are coming again and again. For example, take now 1 by 3 take. What will come? 3. Here is 1. 0 point means 0. 3 3 is 9. Again 1 point is 0. 3 3 is 9. Again 1 point is 0. 3 3 is 9 and etc. This process is going on, but same number only coming again and again. Okay, so what will come here? 0.3 bar. 0.3 bar. It is written as 0.3 bar. So what is 3 bar means? Here only 3 is repeating again and again many times. Many infinity number of times. Like these numbers are called as non-terminating and repeating or recurring decimal numbers. These are the two types of rational numbers. And the next one is, what is irrational numbers? What is irrational numbers? Irrational numbers. Irrational numbers. What is irrational numbers means? The numbers which are not written in the form of p by q are called as irrational numbers. The numbers which are not written in the form of p by q are called as irrational numbers. Example: root 2, root 3, pi, e and etc. Pi, e and etc. Here e also irrational. Pi value how much will come? 3.14. Here e value is 2.178. Pi value is how much? 3.14. Pi value is 3.14. Okay, small e value is 2.178. This is also non-terminating, means so on also will come. So on also, here also so on will come. But we are taking for calculations, only this one only are taking. For pi means 3.14. Now e means 2.178. Only taking for calculations. Okay. And the next one is, for if take any one rational number and any one irrational number. Any one rational number and any one irrational number. The sum of a rational number and irrational number is always be irrational. For example, 2 is rational, root 3 is irrational. Sum will come now. What is this one also? Irrational. Irrational. These are denoted by the letter capital Q dash. Capital Q dash. Take one rational number and one irrational number. The sum of a rational and irrational number is always be irrational. Similarly, subtraction also irrational. Subtraction 2 minus root 3 also what will come? Irrational only will come. Irrational. Now multiplication also irrational. Multiplication means what? 2 into root 3. This one also always be irrational. And then division also take 2 by root 3 or root 3 by 2. Like this anywhere take. What will come? This one also always be irrational number. Now take any one rational number and any one irrational number. The addition, the subtraction, division, multiplication all are always be multiplication of any one rational number and irrational number are always be irrational numbers only. Irrational numbers. Then, for example, if any one fraction is given, without dividing, how to find the number is terminating decimal number or non-terminating decimal number or rational number or irrational number. Mainly rational number or irrational number. If fraction is given, how to find the number is rational or irrational. If decimal number is given, how to find the rational number or irrational number. Now take only fraction form. Now take only fraction form take. Fraction form. Fraction form. Fractional form take. Fractional form. If any one fraction is given, if any one fraction is, if a by, for example, if a by b is a fraction, then a is called as numerator and b is called as denominator. You know already that one. A is called as, if a by b is a fraction, then a is called as numerator and b is called as denominator. Okay. Now how to find the, if a number is rational number, if any one fraction is given. Now how to find means, if the denominator is in the form of, in any fraction, the denominator is in the form of 2 power m or 5 power n or 2 power m into 5 power n. in any fraction, the denominator is in the form of 2 power m or 5 power n or 2 power m into 5 power n. That is always be terminating decimal number. That is always be terminating decimal number. Okay, that is always be what number? Terminating decimal number. Terminating decimal number. Now in fractional form, for example, take in fractional form example. I will come example. Right, say take now 4 by 24, take 4 by 24. Now this one take 4 by what will come 6, cancelled. What will come 1 by 6 is equals to what will come 1 by 2 into 3, 2 power 1 into 3 power 1 is it. Now what form is there in denominator? What we have to have in denominator compulsory only 2 is there or only 5 is there or multiplication of both 2 and 5, product of both 2 and 5. This only is there means that is always be terminating decimal number. For example, without 2, now product of 2 and another number except 5 is there or product of 5 and another number except 2 is there. Like this all many is there means that is always be non-terminating and repeating decimal number. Here what is there? 2 into 3 is there. So 2 is there. 5 not there. What is there? 3 is there. So this is also non-terminating and repeating decimal number. For example, one more take. What will come? Now 3 by 20 take. What will come answer? 3 by 4 into 5 is equals to 3 by 2 square into 5 power 1. 4 means how much? 2 square into 5 power 1. 2 power m into 5 power n formula is there. So the denominator is in the form of 2 power m into 5 power n. So this is always be terminating decimal number. Terminating decimal number. Like this also take. For example, 9 by 2 is there. Only 2 power 1 or for example 4 is there take. 4 is there. What will come? 9 by 2 square. 2 power m formula. These also always be terminating decimal number. We have to check only denominator only, not numerator. If denominator is in the form of 2 power m or 5 power n or 2 power m into 5 power n, that is always be terminating decimal numbers. Otherwise, not terminating and repeating decimal numbers. Not terminating and repeating decimal numbers. For example, this one take 2 power 2 into 7 take. Like this is it. This also non-terminating. Why? Because 2 is there. For example, 5 also take here. 5 square also take. 2 is there, sir. 5 is there, sir. So what will come, sir? Terminating decimal number will come. No. Some roots will come. What I have said. If both is there means again 7 more is there here. 7 more is there. So compulsory only 2 or only 5 or both 2 and 5 only is there. Only 2 or only 5 or both only 2 and 5. This one only is there in denominator. That is always be terminating decimal number. Now this both is there and again any one other number is there means that is always be non-terminating and repeating decimal number. Non-terminating and repeating decimal number. And then next one is, for example, if any one decimal number is given, how to find that is rational number or irrational number. Any one decimal number is given. For example, you see, like this is given 2 by 5 is a rational number. Next one 10 by 12. This is also a rational number. Root 2 is what number? This one irrational number. Now, for example, like this is given means we can find out what is the which number is rational, which number is irrational. But in only like this not given. Only decimal espaces is given. Decimal espaces. For example, take, you know already rational numbers are two types in decimal espaces. First one is terminating decimal and second one is non-terminating and repeating decimal numbers. But in irrational numbers are always be non-terminating and not repeating decimal numbers. Non-terminating and not recurring. Not terminating means what? Infinity numbers is there. Not recurring means what? Same numbers are not repeating again and again. That are the irrational numbers. Now first example take 9.256 is there. 9.256. After decimal point only defined digits is there means what? Finite digits. How many is there? 3 digits. So this terminating decimal number means what? Rational number. This is what? Rational number. Rational number. There is always be rational number. Then next one is For second example, take 10.25 bar take. 25 bubbles, what will come? Z equals to 10.25, 25, 25 and etc. will come. And so on. These also always be rational number. These also always be rational number. For third example, take now 10.25, 255, 2555 and etc. Take 25, 255, 255, let us etc. Take 25 repeated, okay. 25 repeated, okay. Again 5 is there. Again 5 is there. Like this. In inner decimal numbers, the same number is not repeating again and again, and there is infinity numbers means that is always be irrational. This always be Q dash. Q dash means what? Irrational numbers. Q dash is irrational numbers. Then what is real numbers or what is real numbers? Real numbers are denoted by the letter capital R. Capital R. Now what is real numbers? The rational numbers and the irrational numbers combinedly known as real numbers. The combination of both the rational numbers and irrational numbers are called as real numbers. So R is equals to Q union Q dash. Q union Q dash. R is equals to Q union Q dash. Here union means what? Combining both. Union means combining both the numbers. What are they? Rational numbers and irrational numbers. Rational numbers and irrational numbers. Now take one example. You see, this is what will come. This is natural numbers. This is what will come. This is whole numbers. This is what will come. This is integers. This is what will come. This is rational numbers. This is irrational numbers separately. This is irrational numbers. Now combinedly, all are commonly known as these real numbers. This is real numbers. Now you see, now natural numbers are subset of whole numbers. N is subset of whole numbers. What is subset? Now all the elements of natural numbers are in the whole numbers. All the elements in the natural numbers are in the whole numbers. Every element of a set is in the another set. Then that is called as subset of subset. Okay. Now whole numbers are subset of integers or subset of rational numbers. But irrational numbers are separate. Irrational numbers are always be different numbers. So these are the real numbers. What is real numbers? The numbers which are the combination of rational numbers and irrational numbers are called as real numbers. And here one of the most important concepts are the real numbers are irrational numbers or irrational numbers. If any number is rational or irrational, if any number is rational or irrational, but every rational number is always be a real number. Every rational number is always be a real number. But every irrational number also always be a real number. But every real number is need not be rational. Similarly, every real number is need not be irrational. For example, take 2 by 5 is real number and rational also. 2 by 5 is real number and rational. So rational numbers are always be real numbers. Rational numbers are always be real numbers. For example, 2 to 5 take. This is irrational numbers and also real numbers. So irrational numbers are always be rational numbers. Irrational numbers are always be rational numbers. For example, take now root 5 take. This only irrational. This rational will come. This rational will come and also irrational will come. This real number will come and also irrational will come, but not rational. But this one take rational will come, real will come, but not irrational. So what is the term means? Every rational number is always be a real number. Every irrational number is always be a real number. But every real number is need not be rational. Similarly, every real number is need not be irrational. Okay. And then next one is what is surd? What is surd and what is RF? What is surd and what is RF? Surd is also called as radical. Surd is also called as radical. Surd or radical. Now, if A is any positive integer, what is surd? If A is any positive integer and n is any natural number greater than 1. If A is any positive integer, if A is any positive integer and small n is any natural number greater than 1, then nth root A is called as nth order surd or surd of nth order. If A is any positive integer and n is a natural number and small n is a natural number greater than 1, then nth root of A is called as surd of nth order or nth order surd. Here nth root is called as radical or surd. Nth root A is called as radical or surd. Nth root is A is called as radical or surd. N is called as order of surd. Order of surd. Next, nth root is called as radical sign. Radical sign. Radical sign. Now A is called as radicand. A is called as radicand. Radicand, not cull. Radicand. What is surd? If A is any positive integer and small n is any natural number greater than 1, then nth root A is called as nth root A is called as nth order surd or surd of nth order. Here nth root A is called as radical or surd. N is called as order of surd. Nth root is called as radical sign. A is called as radicand. A is called as radicand. Now what is RF? RF means rationalization factor. RF means what? Rationalization factor. Now what is rationalization factor means? The sum of any two rational numbers, the product of any two irrational numbers is a rational. The product of any two irrational numbers is a rational. Then both are called as RF to each other. For example, take root 2 take. Root 2 is irrational. Another root 2 take. Root 2. For example, root 2 only not. For example, what will come? Root 8 take. What will come? Root of 2 into 8. What will come? Root 16 is equals to 4. So, this one irrational number, this one irrational number. Product of two irrational numbers is one rational number. Product of two irrational numbers is one rational number means, so root 2 is the RF of root 8. Similarly, root 8 is RF of root 2. What is RF means? The product of two irrational numbers is always be a rational. Always be a rational. Then both are called as RF to each other. For similarly, RF of A plus root B is A minus root B. A minus root B is A plus root B. Now root A plus root B is what will come? Root A minus root B. Now like this also will come, and root A minus root B means root A plus root B. If plus is given, minus is given, plus. Okay, and then next one is, for example, another form is given like this. Another form is given in RF. In RF, the most important concepts, the formula principles also will come. In last year, in state syllabus 9th class, this topic is not there. But in last year, they asked question. That one means, now if 3 root A is given, 3 root A plus 3 root B. What is the RF of 3 root A plus 3 root B is equals to A power 2 by 3 minus A power 1 by 3 into B power 1 by 3 plus B power 2 by 3. RF of root 3 root A. This is also written as A power 1 by 3 plus B power 1 by 3. This one both are equal. This one both are equal. The RF of 3 root A plus 3 root B or A power 1 by 3 plus B power 1 by 3 is A power 2 by 3 minus A power 1 by 3 into B power 1 by 3 plus B power 2 by 3. Now next one is RF of 3 root A minus 3 root B is equals to A power 2 by 3 plus A power 1 by 3 into b power 1 by 3 plus b power 2 by 3. b power 2 by 3. This is the RF of 3 root a minus 3 root b. 3 root a minus 3 root b. These are most important for 4 marks. Most important. Now in previous years, now what questions in textbooks? The questions only will come for exam. But since 2 years, not textbook questions only not coming for public examinations. Textbook questions only not coming for public examinations. Which concept is it? Based on the concepts, they are asking questions. So we have to learn this one means if will come is easier. If you don't know this one means if you lost 4 marks. Okay, and then next one is what is Euclid's division lemma. In this chapter, most important concepts for 2 marks is Euclid's division lemma and fundamental theorem of arithmetic. Or 1 mark also asks you sometimes. Only statement means this one will come. Now what is fundamental theorem of arithmetic and what is Euclid's division lemma? Now what is Euclid's division lemma? What is Euclid's division lemma? For any positive integers a and b, for any positive integers small a and small b, there exists unique pair of integers q and r. Q and r. For any positive integers small a comma small b, there exists unique pair of integers q and r satisfying a equal to bq plus r. Satisfying a equal to bq plus r, comma 0 is less than or equal to r is less than b. A is equals to bq plus r, comma 0 is less than or equal to r is less than b. What is Euclid's division lemma? For any positive integers, for any 2 positive integers small a and b, there exists unique pair of integers q and r satisfying a is equals to bq plus r, comma 0 is less than or equal to r is less than b. This result was first noted in the 7th book of Euclid's Elements. This result was first written in the 7th book of Euclid's Elements. 7th book of Euclid's Elements. Okay, and then this Euclid's algorithm is used to find the HCF of 2 numbers. Euclid's algorithm is used to find the HCF of 2 numbers. For example, find the HCF of 60, 100 take. Find the HCF of 60, 100. Now take 60 here and is 100 is here take. 60 ones 60. How much will come? 40. Here is 60 here take. This 60 here is here. Now 60 40 ones 40. Here is 20. Now this 60 here take. Now 23 is 60. What will come? 0. 0. Now how to write the Euclid's? How to write Euclid's algorithm? How to write Euclid's algorithm take? Now 100 is equals to 60 into 1 plus 40. 100 is equals to 60 into 1 plus 40. And then next step 60 is equals to 40 into 1 plus 20. 40 into 1 plus 20. And then sorry, this 20 take here. This 20. This 40 here take. 40. 22 is 40 is 0 will come. Now what will come next? 40. 40 is equals to 20 into 2 plus 0. If remainder is 0. Now dividend what is there? That is the HCF. So HCF is equals to what will come? 20 is the HCF of 60 comma 100. Now at the time of which time the remainder is equals to 0, that case now divisor what is there? Sorry, divisor what is there? Divisor how much is there? That is the HCF of the given 2 numbers. That is the HCF of given 2 numbers. And then next one is fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Now, what is fundamental theorem of arithmetic? Every composite number can be written in the form of product of their primes. Every composite number can be written in the form of product of their primes, and this factorization is unique apart from the order in which prime factors occur. Now, for example, any one composite number take. For example, 15 is a composite number. What will come? 3 into 5. This is composite number. Now both are prime numbers. 15 is composite number. Now 3, 5 are prime numbers. So every composite number it can be written as product of their prime numbers. So this is the Euclid's division lemma. Fundamental theorem of arithmetic. This is fundamental theorem of arithmetic. Fundamental theorem of arithmetic says that every composite number can be written in the form of product of their primes, and this factorization is unique apart from the orders in which prime factors occur. Next, another form is all the natural numbers except 1 is written as product of their primes. All the natural numbers except 1 can be written as product of their primes. Now, what is prime? You know what is prime numbers already. What is prime numbers? The numbers which have only one factor. The numbers which have only one factor other than 1 is called as prime numbers. The numbers which have only one factor other than 1 are called as prime numbers. Now, what is composite numbers which have 2 or more factors or other than prime numbers are called as composite numbers. But 1 is neither prime nor composite. Okay. Next one, logarithms. For example, in any logarithmic form, you know what is exponential form already. Exponential form. For example, if logarithmic form is given, convert into exponential form. If exponential form is given, convert into logarithmic form. Now, how to find that one? For example, take now log x. A power n equal to x take. A power n equal to x. A power n is equals to x. This is this exponential form. In exponential form, what is the base? Here base is a power n is there. Here a is the base and n is the power or degree. Now we have to convert this one into exponential form. Is here n is equals to. Here base what is there? A is there. In logarithms also base compulsory will come. In exponential form base what is there? In logarithmic form also base same will come. So this is written as log x base a. This base a is gives to base log x. This is written as log x base a. Writing also first writing means log x base a. Some members is there. Writing like this. Log a and x like this writing. This is fault. This is wrong. Writing one like this one. Log x first and then base a. If exponential form is given, a power s is equals to a power n equal to x, then n is equals to log x base a. Here base what is there? Here also base same will come. Here base what is there? Here also base same will come. For example, take what is that one? 3 square equal to 9 take. 3 square equal to 9. Convert this one into logarithmic form. Here base what is there? 3 is there. Then take. Here n equal to means 2 is equals to. log 9 base 3. This base is what is there? 3 is there. Here also base is 3 will come. This is the if exponential form is given, then converting into logarithmic form. For example, if logarithmic form is given, then converting into exponential form. This one only take n into log x. N is equals to, for example, like this take log x base a. Log x base a is equals to n take log x base a equal to n is a. Now convert this one into exponential form. Here x is equals to here base what is there? A is there. In exponential form also base a only will come now. So here will come, this one goes to up. A is a power n. X is equals to a power n. This is the exponential form when logarithmic form is given. These are most important. For example, like this is given. Now 2 power n is equals to 8. 2 power n is equals to 8 is given. You know how to find value of n. 2 power n is equals to 2 cube. N is equals to 3 will come. N is equals to 3. If a power m is equals to a power n, then m is equals to n will come. So according to that formula, n equal to 3 will come. But question is, convert that one into exponential form. This one is given now. Convert that one into logarithmic form. So this one 2 power n equal to 8. Convert that one into logarithmic form and then find the value of n. 2 power n is equals to 8 is given. Convert this one into logarithmic form and then find the value of n. Now logarithmic form means n is equals to log 8. This base 2 is there. Here also 2 will come. Now log 8 means what will come? 2 cube and 2. We have a power n formula 3 into log 2 base 2. This formula is log of x power n formula is equals to n into log x. Log of x power n formula n into log x. Then what will come? This value is 1. So 3 into 1 is equals to 3. This is the answer. Answer is same will come. But which method is it? Do that method only. And the next one is some more important form. And also logarithm of negative numbers are not defined. Here both numbers is there now. Here both the numbers are compulsory always be positive. If any one number is negative, for example, this one is negative, this number is not defined. For example, this both are negative, this is also not defined. For example, this only one is negative, this one also not defined. And some more important formulas in this logarithms are first one is log of xy is equals to take log x base a plus log y base a. Here multiplication means there is addition. And second one is log of x by y is equals to log x base a minus log y base a. And then third one is base a take log x power n base a equal to n into log x base a. And fourth one is log a base a equal to always be 1. Log a base a, log 2 base 2, log 4 base 2, log z base z are always be 1. For example, fifth one is here logarithms is there now. For example, take log x base a means here a is always be not equal to 1. A is always be not equal to, base is always be not equals to 1. So for example, log 1 is always be not defined. Log 1 is always be 0. For example, sixth one take log 10 base 1 is always be not defined. Log 1 base 10 is always be not defined. Why? Because base is always be not equal to 1 means what? Greater than 2. Base is always be greater than 2. Means what? 2 or more than 2. And also not negative. And then next one is here see log x power n base a is there. Log x power n base a. Then how to find the here n is here will come. Log of x base a power n formula what will come? 1 by n into log x base a. 1 by n into log x base a. And another formula, each one is log of x power m base a power n is equals to. x power m is what? M will come. Y power n means by n will come into log x base a. Log x base a. Okay. And then next one is, for example, ninth one, a power log n base a is equals to n. A power log n base a is equals to n. If this one and this one both are equal, is there? Here value how much is there? Same value, a will come. These are the some more important formulas in the logarithms. Here, what are the three formulas? What are the most three formulas in logarithms? First one is this is called as first law of logarithm. This is called as second law of logarithm. This is called as third law of logarithm. This is called as first law. Log of x into y base a is equals to log x base a plus log y base a. Okay. Now log of second law is log of x by y base a is equals to log x base a minus log y base a. And third law, log of x power n base a is equals to n into log x base a. Now how to find the proof of these laws? These are also these proofs are not necessary but I will explain what is the how will come proof. Now first law, proof of first law. What is first law? Log of xy base a is equals to log x base a plus log y base a. Now proof take. Let x is equals to a power n, comma y is equals to a power m. Take x is equals to a power m, comma y is equals to a power n, and then take convert this one into exponential logarithmic forms. Convert this one into logarithmic form. Okay, what is logarithmic form? Logarithmic form. What will come? This basis here will come now. So n is equals to log x base a will come. This one m is equals to log x log y base a will come. N is equals to log x base a and m is equals to log y base a will come. Okay. Now we know that formula. We know that a power m into a power n. A power n take first. A power n into a power m is equals to a power m plus n or n plus m. We know that a power m into a power n into a power m is equals to a power n plus m. Okay, a power n means what here? X into a power dot take here x is there now. So for understanding x into a power m is what? Y is equals to a power n plus m. A power n plus m. Then take here, this is one of the exponential form. Convert this one into logarithmic form again. Convert this one into logarithmic form means this is coming to here. Base will come. So what will come? Log of xy base a is equals to n plus m. Log of xy base a is equals to n plus m. Then take log of xy base a equal to n means what? N means what? Log x base a. N means log x base a. Log x base a plus m means what? Log y base a. Log y base a. This is the answer. This is the proof of hence proved. This is the proof of first law. This is the proof of first law. Okay, what is first law? Log of xy base a is equals to log x base a plus log y base a. This is the proof of first law. Okay, now for example, second law take. What is second law? Second law take. Okay, second law means okay. After this one actually, second law. Now x by y. This second law. X by y, a minus will come. Log of x by y base a equal to log x base a minus log y base a. Okay. And then what will come? This one with this x equal to a power n comma y equal to a power m, same take. Now converting into logarithmic form means n equal to log x base a comma m equal to log y base a will come. And the next one, we know that formula, exponential form, exponents a power n by a power m is equals to a power n minus m. A power m by a power n is equals to a power n minus m. A power n means what here? X. By a power m means what? Y. Y is equals to a power n minus m. A power n minus m. Convert this one into exponential, logarithmic form. This a is base a is no. Come into here. Log x by y base a will come. So log of x by y base a equal to n minus m. Now log of x by y base a is equals to n means what here? N means log x base a. Log x base a minus m means what? Log y base a. This is the proof of second law. Proof of second law is proved. This is the proof of second law. Okay, and then third law what? Log of x power n base a equal to log of x power n base a is equal to what will come? N into log x. How to find that formula? Proof of third law, take next. Proof of third law. Third law. Log of x power n base a equal to n into log x base a. This is the third law. Now take proof. Let x is equal to a power m, take x is equal to a power m. Convert this one into logarithmic form. What will come? Log x base a equal to m will come. Log x base a is equal to m. Okay. Now this equation 1 take. Equation 1. Now take powers on x n. Now from equation 1 multiply powers with n on both sides. Multiply powers with n on both sides. X1 means what? Power 1 is there here. So x into n. X power n is equals to a power m whole power n. X power n is equals to like this will come. So x power n is equals to what will come? A power mn. Now this exponential form. Convert this one into logarithmic form. So this base is coming to left side means what will come? Log x power n. Log x power n base a is equals to m into n. Log x power n base a equal to m into n now. So log of x power n base a equal to n separate take. M is what is there here? Log x base a. N is separate take. First take n. Then m plus what is there? Log x base a. N into log x base a. This is the proof of third law. Hence proof. This is the proof of third law. Okay. These are the topics in this chapter. Okay. Now the next one is. Now first one most important concepts in this chapter is Euclid's division lemma, fundamental theorem of arithmetic, and then the next one decimal expressions of rational numbers and logarithms. 4 marks is most important in logarithms only, and also show that root 2 is irrational number, 2 plus root 3 is irrational number, root 3 plus root 5 is irrational number. This is also most important for 4 marks questions. Okay, thank you all.